Hi math students! Today we are doing our Unit 2 review because you did it. You have finished another unit at this point. Just a reminder of what we learned in Unit 2. We learned 5 skills. We spent a day talking about multiplication, a day talking about division, a day looking at multiplication and division word problems, then a day talking about how you multiply and divide integers or multiply and divide negative numbers. And then our last lesson was a day on how you use exponents and square roots and how you simplify them. So at this point, if you have not already, make sure you've watched those 5 videos before you jump into the review video. This, again, just like with Unit 1, is inspired by the homework questions that you at home have missed the most. So I came up with questions based off of problems I saw a lot of students were making to make sure we've talked through some of those issues a lot of you seem to be having before you take the Unit 2 test. So I have got 5 problems in this review video that we're going to look at starting now. So this first one is a word problem inspired by our lesson on word problems. In this one, it tells us, last week, Martin bought 7 pizzas for students, which cost $84. He needs to buy 6 pizzas this week. How much would that cost? Go ahead and try it now to see how you do. All right. If I'm trying to figure out how much would 6 pizzas cost, we're trying to find the cost of 6 pizzas. The first thing we're going to need to know, if I want to know how much 6 pizzas cost is, well, how much does 1 pizza cost? If I know the cost of 1 pizza, I could just multiply it by the 6 pizzas. Unfortunately, in this problem, they didn't tell us what 1 pizza cost. This is an example of a word problem that has more than one step to figure out the answer, which is something I saw a lot of students were struggling with at home. In this problem, we are going to need to know the cost of 1 pizza first, and then once we know the cost of 1 pizza, we can find the cost of 6 pizzas. Now, we had already said, I noticed they don't tell us the cost of 1 pizza. What do they tell us? Well, they tell us 7 pizzas cost $84. There is a way to use that information to find this first part, the cost of 1 pizza. If I know 7 pizzas cost $84, I could divide that to figure out the cost of 1 pizza. We want to start off by doing the $84 divided by our 7 pizzas. Now when I do that, it's going to give me an opportunity to review what we learned about multiplication and division by hands. This is a problem where I would want to use long division to divide. Instead of thinking how many 7s go into 84, we can start by thinking how many 7s go into 8. Well, if you're counting up by 7, it goes 7, 14. 14 is too many. That means 7 only goes into 8 one time. When we do that, some of us like to say, well, 7 times 1 is 7, and then use that to help you find the remainder. 7 goes into 8 one time, and there is a remainder of 1. Now that I finished doing 8 divided by 7, the next part is bring down our 4 and divide again. 7 goes into 14 2 times. So my 2 goes up there at the top. Then we could say 2 times 7 is 14 and subtract to show that the remainder is 0. I got my answer is 12. What did I just find? What is 12? Well, remember, we were dividing $84 by 7 pizzas. When I get 12, what I've just found is the cost of 1 pizza. I found the cost of 1 pizza is $12, and I've done that part. Now that I know the cost of 1 pizza, I can use this information to find the cost of 6 pizzas. Now there's a couple ways you could do it. You could say, well, if I've got 6 pizzas, times 6, this first pizza costs 12, this next pizza costs 12, 12, 12, 12, 12. And then to find the total cost, you could add and add and add. That is definitely one way to get the answer. That might be one of the ways that someone at home did. But there is an easier way. Instead of using all of that addition, instead we could say, let's just take the cost of 1 pizza and multiply it by 6 pizzas. So I could find the cost of my 6 pizzas by doing the $12, the cost of 1 pizza, times our 6 pizzas. This also gives us a perfect chance to review multiplication by hand, since that's what we did in our first lesson. If I want to multiply this, I start with my 6 and do 6 times 2, which gives me 12. I put the 2 from 12 there and I carry my 1, and then we multiply again. We say 6 times 1 is 6. Don't forget about that 1 you carried. 6 times 1 is 6, plus that 1 gives me 7, and we get 72. Again, I did 12 times 6, that gave me 72, but what did I just find here? What does 72 represent? Well, remember what we were doing. We were multiplying the $12 times 6 pizzas. We found that when you do that, it costs a total of $72. Now, if I go back to my problem and check, that's what we were trying to figure out. We're trying to find out how much would 6 pizzas cost. We've got our answer. I could say, I'll put it over here, 6 pizzas cost $72. Now, the other thing I feel like across the board, a lot of you have gotten a lot better on is explaining your thinking, justifying those parts of the question where I asked you to like write out essentially what you did. If I asked you a question like with this problem, what I would say is something like there's 2 steps. Step 1 is finding the cost of 1 pizza by dividing. Step 2, to find the total cost of 6 pizzas, you want to multiply $12 times the number of pizzas. It doesn't have to be big and fancy. Just make sure it's clear what you did. Sometimes I'll see things like, well, I divided. Well, that's not the only thing you did. You divided, but that wasn't your final answer. What else did you do? So make sure you're telling me everything. Other times I'll see things like, I divided and added. Well, you divided what? You added what? So make sure you're giving me details, but it doesn't need to be this huge like paragraph of an answer. Just make sure you're specific with what you did. This is our first problem we've got for our review. The next one's going to be a little different. Okay. The next one says, write a multiplication and division problem that would equal -4. For these ones here, there are a lot of different answers you can put. Don't feel like there's only one correct answer, but go ahead and try. Give me a pair of numbers that multiply to give you -4, and a pair of numbers that would divide to give you -4. All right, the way I do these is I like to pick a pair of numbers first that would give me just 4, and then use what we know about negative numbers and signs and multiplication and division of integers to help me figure out what signs I need. So for example, if I'm trying to figure out what numbers I could use here, the first thing I'm going to ask myself is, well, don't worry about negative. What are just 2 numbers that I know multiply to 4? I'm imagining most of you at home either put 1 times 4 or put 2 times 2. You can get into like crazy fractions and decimals, but I'm guessing this is what most of you did. On the homework, I saw a couple 0 times 4s or something similar to that. Be careful with that 0. If we're talking about 0 plus 4, if you have nothing, let's turn it into money, right? You have no money, I give you $4. That would mean you have a total of $4. But when you're multiplying, remember this means you have 2 groups of 2. You have 2 and 2. 0 times 4 means you have 0 groups of 4. Anytime you're multiplying by 0, the answer will be 0. So you could not put 0 times 4 for this. Now I've got 2 pairs of numbers here that multiply to 4, but I want a pair of numbers that multiplies to -4. So I'm not done. I still need to do something with my signs. In order to answer this question, we need to go back to what we know about multiplying integers or multiplying negative numbers. There were 2 rules we learned. One is when you multiply different signs, the answer is negative. That means if you have a positive and a negative and you multiply them together, the answer is always going to be negative. And then the second rule is if you multiply two negative numbers, the answer is positive. So if I've got a negative times a negative, my answer always, always, always will be positive. Here, I want my answer to be negative. That means the signs need to be different. Doesn't matter which one you make negative, but we need one to be negative, one to be positive. So you could do something like this. You could also do something like that. Down here, it doesn't matter which one's negative. You could have the first two be negative. You could have the second two be negative. All four of these are going to give you -4, which is why I said there's so many options. Over here for division, there really are a lot of options. There are infinitely many numbers that you can divide to give you 4. I think some of the more common ones I see would be like 8. What's my hand doing? 8 divided by 2. You could do 12 divided by 3. Maybe 40 divided by 10. We could do 16 divided by 4. There are, like I said, a lot of options, and this is just a few of them. What I would point out is make sure here you have the larger number first. On the homework, I saw some 2 divided by 8s or something similar to that. This and this do not mean the same thing. This here, we would be asking ourselves how many 8s go into 2, and it doesn't. If you tried making it, I don't know, like pencils. If I had 2 pencils that I'm dividing up amongst 8 students, you can't do that. But if you have 8 pencils that you're dividing between 2 students, you can do that. Division, at least when we're talking about like nice whole numbers, not fractions and decimals, we want that larger number to come first. So like I said, these are 4 options. There are many, many more. Again, like before, there's still that negative sign we need to worry about. Similar to multiplication, division, if you have different signs, the answer is negative. And if you have the same sign, the answer is positive. Since I want my answer to be negative, it means for these numbers, I need one to be negative and one to be positive. Also, like before, it doesn't matter which one. So you could have the first number be negative, the second number be negative, the smaller number be negative, the larger number be negative. Doesn't matter as long as you've got one positive and one negative, the answer will be negative. Lots of options for these, which is why I like them. It's kind of like you're being the teacher almost, right? Like you're creating the question, which I think as your actual teacher is very fun for me to see. This is our second example. This was really focusing in on what we learned about multiplying and dividing negative numbers. The next question relates to our lesson on exponents and square roots. One of the things I noticed on the homework that some students were struggling with was not actually simplifying the exponents and square roots, but instead this idea of finding a missing number. So there's 2 questions here for us to practice with. They both have the same question. What is the missing number for this problem? And what is the missing number for this problem? It's a little hard to see, but it is, we're trying to find what number is inside that square root. What would this missing number here be? All right. The part of the lesson that this is focusing in on is the idea that exponents and square roots are opposites. Specifically, square rooting and squaring numbers are opposites. What I mean by that is if you are struggling to figure out what number goes here, you can instead do the opposite. So instead of thinking of what number squared equals 64, I can do the opposite of squaring, which is square rooting, and I can take the square root of this number to get my answer. So maybe you're not sure what number squared equals 64, but if you use the fact that it's opposite to square root, the square root of 64 is 8, and that right there will tell you the answer. If the square root of 64 is 8, then 8 squared must equal 64. The other mistake I saw a lot is what this actually means. I know it is so tempting to see this and say, oh yeah, 8 times 2, 16. But remember, that's not what this exponent here means. That tells you are multiplying this number twice. You're putting 8 in two places. What I mean by that is 8 squared is the same thing as 8 times 8. It means you're going to write this number twice using multiplication. 8 times 8 is 64, so that's a good way for us to check our answer and know that we did it right. Now down here, I have given this problem in class before, and ooh, let me tell you, so many people want to tell me 10. And I understand why, right? You see 100, you see a square root, and the square root of 100 is 10. But notice this is not what the question's asking. It is not asking you what the square root of 100 is. It is asking you the square root of what number equals 100. For this one here, I think it's helpful, just like before, to use the fact that square rooting and squaring are opposites. So instead of trying to wrap your head around the square root of what number equals 100, do the opposite. The opposite of square rooting is squaring. So instead of thinking of this, I can ask myself 100 squared equals what? This is going to be the same number that goes right here. 100 squared, well, that means 100 times 100. That is going to be a big number. It's not 100 plus 100. It's not 200. 100 times 100. Let's first do it by hand, and then I'm going to show you a trick. By hand, you start with this first number here, this 0, and you say 0 times 0 is 0. 0 times 0 is 0. 0 times 1, 0. Remember, anytime you're multiplying by 0, it gives you 0. We switch over to the next number, this 0. 0 times 0, 0. Because I'm doing this number here now, that means when I start all these zeros, I'm going to start there. So we got 0 times 0, 0. 0 times 0, 0. 0 times 1, still 0. And then we switch to this last one here. I do 1 times 0, 0. Because I'm doing this 1 right here, I'm going to start below the 1. So when I say 1 times 0 is 0, that 0 is going here. 1 times 0 is 0. 1 times 0 is 0. And then the last one, 1 times 1 is 1. The last part of this is adding all those rows up. Some people like to fill in these empty spaces with zeros just so you can see that there's nothing there. But at the end of the day, you get 0, 0, 0, 0, and 1. Because there's so many digits, I am going to add a comma in, start from the end and count over 3 numbers, and that's where your comma would be. So we get 10,000. Now I said I was going to do this by hand and then I was going to show you a shortcut. Notice all of these zeros in here. I'm sure you did because you probably got tired of me saying 0 so much. But when you are multiplying numbers that end with 0, if you're doing it by hand, it ends up just looking like a lot of zeros on your paper. Instead, a trick you can use is just multiply the numbers that aren't 0. So in this problem, 1 times 1 is 1. And then count up how many total zeros are in the problem. And that's how many your answer will have. So I have a total of 1, 2, 3, 4 zeros. So my answer has 1, 2, 3, 4 zeros. You can do that trick for any multiplication problem that ends with zeros. So something like 30 times 400. Instead of doing all of this again, you could say 3 times 4 is 12. And then 1, 2, 3 zeros means 1, 2, 3 zeros. Fun fact. Not super related to what we're doing though, so I'm going to stop doing that. But coming back to our problem, it was what is the missing number? We figured it out at this point. We've got that missing number was 10,000. Ooh, there it fits. Remember when you're talking about square roots, what a square root means is what number times itself gives you this number inside. So earlier, the square root of 64 equals 8, because 8 times 8 equals 64. Same idea here. Square root of 10,000 is 100, because 100 times 100 equals 10,000. So it's multiplication but reverse. It's actually similar to division, but it's like a special type of division. This is our third review question, related back to what we had said about square roots and exponents. The next question we're going to look at is kind of like a mixture of review, I guess, on a couple different skills we had learned. This one here is asking which problem below has the largest product. There's probably a word in that sentence that you're like, I'm sorry, what? And that is the word product. This is a word we learned in our multiplication and division lesson. We learned that product is the name for the answer of a multiplication problem. So what I mean by that is if you have like 2 times 3 equals 6, 6, our answer, we call the product. It's the name for the answer only when you're multiplying. So it's their fancy way of saying multiply all of these, which one has the biggest answer. Now looking at the problems, we've got 3 options. I see this middle one here has got a negative number in it, and then these other 2 are just nice positive numbers. In order to answer a question like this, if I want to know which answer is the largest, the only way we're going to know that is if we do the math for all 3. If I do the math for just this one, I'm not going to know if it's bigger than the other ones unless I figure out what all of them equal, and then I can compare the answers. So keeping that in mind, go ahead and try this one. Which problem below has the largest product? All right, well, starting over here, if I wanted to do 123 times 5, we've got 3 times 5 is 15. I write my 5, carry my 1. 5 times 2 is 10, plus the 1 I carried gives me 11. Write my 1, carry another 1. 5 times 1 is 5, plus this 1 here gives me 6. And we've got the product, to use some of that vocabulary, we've got the product for this first problem is 615. I'm going to also take this moment just to remind you all why I am doing all this math by hand. Again, I know we all have calculators, but remember, part of the purpose of this class is to prepare you for whatever comes after your time with me, right? And a lot of the tests for graduation, including tests like ASVAB, AccuPlacer, certification tests, a lot of those tests I just named have math sections where you don't get a calculator. So I want to make sure we're using this time very purposefully and giving you opportunities to practice it by hand so that when you're taking the certification test for a certification you really, really want, if you get math problems like this, you know how to do them by hand and you're able to pass that test with or without a calculator. So I'm done, but just a reminder of what we've said in a couple previous lessons. Continuing on with our problem, we got 615 for this first one. I'm going to come over here and do the same thing for the second one. Got negative 183 times 6. When I go to multiply this one, 3 times 6 gives you 18. 8 times 6 gives you, do you know? 48, plus the 1 gives you 49. Write my 9, carry my 4. 6 times 1 gives you 6, and then plus our 4, 7, 8, 9, 10. So we get 1,098. Now notice I was multiplying a negative and a positive. We had just said in a previous problem, when you're multiplying different signs, your answer is negative. There's one last There's one last problem here to multiply. We've got 309 times 2. When I go to multiply 2 times 9, that gives me 18. 2 times 0, remember if you're multiplying by 0, it's going to be 0. Just think of me saying all those zeros in that previous problem. 2 times 0 is 0, but we still need to add in that 1 we carried. So 0 plus 1 gives you 1. And then the last part, 2 times 3, gives you 6. So we get 618. Let me put that here. And that answer there. Okay. So we've done the math for all 3. The question is asking which one has the largest product. Do you know which one it is? Well, it might be tempting to pick this one here, because if I'm looking at 1098 is larger than either of these numbers. But if you're looking at this and only saying to yourself 1098, you are not reading the entire number. This isn't 1098. This is negative 1098. And one of the things we learned back in Unit 1 with negative and positive numbers is negative numbers are always going to be smaller than positive numbers. You think about these all as like possible bank account amounts. I do not want this. This is not the biggest bank account amount. This is you owe that money. It's money you don't have. This is actually the smallest amount. So this is not going to be our answer, despite the fact that it does look like the largest number. Instead, 615, 618, this one here is going to be our largest product. Now, I had said earlier you need to do all of the math, and I think it was very helpful for us to do all the math, but there was something I didn't technically have to do, and it goes back to this problem here. If I just look at these signs, I can see my answer is negative, and I could have said from the very beginning, I don't need to do this problem because the answer is going to be negative. I know these two answers are going to be positive, so I could have said like, hey, this one's negative, it's definitely not going to be the right answer, and kept myself from having to do the math. But I do think it is a good strategy to do them all just to confirm and make sure. This was our fourth review problem. There is only one left for us to look at. And this last one is going to be an example of an error analysis problem. What I mean by error analysis, that is just a fancy way of saying we are going to look at someone's work and find the mistake. Now, like I had said before, I think you guys have gotten so much better in the past 4 weeks. You've improved so much with your written responses. In this past unit, one of the questions I started giving you were these, where you're looking at some work and trying to find the mistake, but we hadn't done one yet in the video lessons. So this is an opportunity to kind of show you a strategy for doing these problems and what a strong answer could look like. So here we've got Sarah completed the following division problem, but made a mistake. What mistake did she make? And we've got all the work over here for it. Now, one thing you can do is you can go through the problem looking at their work, doing it step by step, and try to find the mistake that way. However, what I have found with students in class is sometimes the mistake they make could be very convincing if you're trying to do that way. Like, oh yeah, 1, 3, 2, looks good, looks good. And it makes it really hard to find the mistake. Instead, what I like to recommend students do is don't look at the work at the beginning. Go ahead, do the problem yourself, and then you've got your work that you're more confident with because you did it. You can compare your work with the student's work and find the mistake that way. So keeping that advice in mind, go ahead and try doing just this first part here. See if you can find what mistake did she make. All right, so if I'm taking my own advice and saying, let me not look at the work yet, let me just do the problem myself. We've got 783 that we are dividing by 6. When I do that, 6 goes into 7 one time. 1 times 6 is 6, which is how I show that the remainder is 1. I can bring down the 8 next and divide again. So 6 goes into 18. Well, if you're counting up by 6, 6, 12, 18, it goes in 3 times. And 3 times 6 is 18, which means there is no remainder left. Last step, bring down that 3. 6 goes into 3 how many times? It might be tempting to say 2, but that's 6 divided by 3, not 3 divided by 6. We're trying to see how many 6's go into 3. 6 doesn't go into 3, so that will be a 0. We can say 0 times 6 is 0, which means you've got a remainder of 3. You got a remainder of 3 because it didn't go in those 3. So we can come up and then say remainder 3. Now looking at my answer and her answer, I see we got different things. So that already is helpful for me to figure out, well, where did we do different things? Where is the mistake? I can start following along with her work now that I've got my work to look at. So I could say 6 goes into 7 one time, 6 goes into 7 one time. Okay, looking good. 1 times 6 is 6, 1 times 6 is 6. Okay, looks good. Subtract remainder 1, subtract remainder 1. Okay, bring down the 8, bring down the 8. Okay, it's all good. 6 goes into 18 3 times. 6 goes into 18 3 times. Okay, good. 18 minus 18 is 0. 18 minus 17 is 1. And just like that, you can figure out now where the work is different. Now, one of the things with math is if I make a mistake in the middle of the problem, it means the rest of the work is going to be different. So if you look here, she's got a different number here, different number here. These are different from what I've got. That's because this is the initial mistake. Everything else is going to change once she fixes this mistake. So when they're asking you what mistake did she make, you don't need to describe everything, just what that initial mistake is. If you were in the classroom here with me and I came over and this was your work, I'd point out this part, because once you figure out this part and you fix it, you'll be able to take over with the rest. So one of the things I've noticed in students' answers is they'll be like, oh, well, she's got 17 here, which means she's got 1 here, and then she's got 13 here, so she's got 2, and they keep going, which isn't wrong, right? Like, you're just trying to help her out and do the rest of the problem for her. But with these, like, find the mistake problems, don't worry about doing everything, just the initial thing, which we found at this point. So we've got to look at her work. Where did our 18 come from? Well, our 18 came from 3 times 6 gave you 18. She's got 17 though, which means what was she thinking? Well, she must have been thinking 3 times 6 was 17. So see how having this work here can really help you find these mistakes? If I want to answer what mistake did she make now, I bet you can probably say it because it's just a summary of everything we said, right? The mistake she made is she said 3 times 6 is 17. Now, the other thing that's helpful to include is we'll help her out, like fix it for her. What should it say? So we could say, I'll put it over here. We could say, Sarah made a mistake by saying 3 times 6 equals 17. She should have said 3 times 6 equals 18, something like that. You could also say something like, she said 6 goes into 18 3 times with a remainder of 1. Maybe that's what some of you at home were thinking. So you could say that too, that she said 18 divided by 6 is 3 remainder 1, when 18 divided by 6 is 3 remainder 0. For these, there are always lots of different ways you can say the same thing. But this is just one example of what the correct answer could look like. Now notice the second part is asking what is the correct answer? Well, hey, how nice. We've already done that part. We can go ahead and just copy down our answer, say 130 remainder 3. And that would be our final answer for this one. That is all of the review questions I've got for this. This is one last reminder that we've got the Unit 2 review, and then what's going to come next is the Unit 2 test. Make sure before you take that test that you have done all of the Unit 2 material. If you're watching this video, you should have already watched the first 5 videos for this unit. But before you take that test, just confirm that you have watched all the videos, because I imagine it's very confusing taking a test if you have not watched one of the lessons that the test is on. If you're not sure if you are all good to go with Unit 2, feel free to reach out to me or Denise and we can help you out. But do confirm that you are all up to date on your Unit 2 stuff before you take the unit test. That is all I have to say about that. Good luck on your unit test, and I will see you guys for the next video where we start Unit 3. Bye.